We are Group B1. So today we are going to present our feasibility studies for the previous task. So let us introduce ourselves first. My name is Tan Suat In.
My name is Sazi Khalifa.
My name is Nuraifa Liana.
My name is Divya.
My name is Muhammad Azim Ismail.
Okay, so let us present with our task 1. Okay, so for our task 1, so this is our organizational chart, and then Azim is the design manager, Divya is the economic engineer, and I am the production engineer, and Ifa is the process engineer, and Ifa is site engineer. And this is for our timeline, which is task 1, task 2. You can see the date respectively, which is starting from task 1 is 8th of March, and then task 6 is ending at 13th of May.
Present about task 2. Okay, first we start with QFT is quality function deployment. Actually, it is a method of transform qualitative user requirements into quantitative parameters. We usually start with the customer requirements, and then we list the characteristic of the what customer wants, and then after that we scale up for each of the characteristics. So the middle one is the design of engineering, what customer wants, and then the left side is the competitor assessments. Okay, the next one. Okay, our design philosophy is first to outline a plan that deliver high return of hydrolyzed soybean protein and build up a plan that meet for the GMP principles. Besides, we also to outline the economical plans and to boost the well-being of plants. Lastly, is to limit the development of waste items. Okay, our raw materials is soybean. We choose soybean because soybean is high content of high protein, and our reaction of mechanism, especially in enzymatic hydrolysis, which peptide bonds is broke by the addition of water in enzymatic hydrolysis. Okay, for our product, by our products is first is soybean hull. Soybean hull is produced during dehydrating and cracking, and second is soybean oil, which is during solvent extraction process, and the lastly is endotoxin, which is during the ultrafiltration process. Okay, our process specification. First, we receive the raw material from the plantation of soybean, and then we undergo the process cleanup. The second is the process will undergo dehydrating and cracking. Then we undergo the process of baking, which is to destroy a cell of soybean to improve the efficiency of the next process. And then the next process is solvent extraction. In solvent extraction, we use sand to process washing, and then the next one we will mix with water. After we mix with water, fermentation, the soybean will undergo fermentation. In fermentation, there will occur enzymatic hydrolysis, where the peptide bonds will be broke. The next process is filtration and ultrafiltration, and then the raw soybean will undergo spray drying with high temperature. The last is packaging and storage. Okay, our competitor analysis is AA Sansun Seng, and also Ajinomoto, Industries Laborhat, and Aipu Food Industry, and Joy Ingredients. Our plant capacity for our plant design is proposed to produce 2,000 megatons hydrolyzed soybean protein pound annually. And our raw materials plant capacity is soybean for about 3,000 tons, genus Orize, culture 100 kg.
Okay, for the task 3, for the customer, we focus around individual market and supplier for food and beverage industry. Our raw material we import from China. Hexane is used to remove oil in soybean during solvent extraction, and aspergillus organ is needed for enzymatic hydrolysis. Our design of the project is to produce hydrolysis soybean protein powder under technology of spray drying from the primary raw material of soybean. Our product target is to reduce the processing time and produce a high yield of spray dry hydrolysis soybean protein powder. Our objective is to outline a plan that deliver high yield of end product, to build up a plan that meet the GMP principle, to boost the well-being of plant, to limit the development of waste item and to be environmental friendly. Okay, for the enzymatic hydrolysis, which is a vital by process to improve the physical, chemical, functional and nutritional properties of original proteins. It is effective to prepare active peptides because it has many physiological properties. Proteins are placed in an aqueous suspension for preparation of enzymatic hydrolysis. Protein needs to place in water suspension at the appropriate pH. So for the advantage of enzymatic hydrolysis is enhance the natural character of food, provide a unique complexity in product, healthiest product, can be carried out at normal temperature and pressure, reducing the energy consumption of the process. Further disadvantage. Impact of enzymatic hydrolysis to society and environment. Effluent released from the process contain organic compound such as acetic acid. If effluent does not untreated, it can damage the soil characteristic and deplete the dissolved oxygen present in the surface of water. This is the spray drying that we choose. The advantage of spray drying, why we choose spray drying, is because it short resistant, time required, homogeneous solid mixture product produced, can operate at relatively low pressure. Particle size can be changed by changing the waste speed. For the disadvantage is high capital and overhead cost, fire hazard may result. Impact of spray drying to environment is it can cause fire hazard if there is careless or misconduct of processing of the equipment. For example, an organic powder may explode if there is an ignition sources within the plant. Okay, this is our block flow diagram, process flow diagram. This is our block flow diagram.
Okay, for task 4 is about mass energy balance. So this is the physical property of something. As we can see, they have density, porosity, terminal velocity, bulk density, moisture content, and bulk thermal conductivity. And the table beside there is the range for these physical properties. Okay. This is the energy balance for each process. First process, dehuling and cracking. The assumption is it has a constant and equal granulation after the cracking rolls. The pressure and temperature of the entire process remain constant. The speed remain constant. All the hulls of soybean are removed in the dehuling process. No energy balance is needed in this unit operation. No accumulation of mass or energy balance in the system. Temperature of pressure operating condition is 30 degrees Celsius and 180 N. So the overall mass balance for dehuling and cracking is 460 kg per hour. There is no energy balance, and the composition for dehuling and cracking is protein is 40.26%, fat is 19.57%, carbohydrate is 24.96%, water is 8.69%, mineral 6.52%. For the flaking, the assumption is assumption for flaking is similar with the dehuling. So the mass balance is the overall mass balance is same with the dehuling, 460 kg per hour, and the composition is Same with the dehulling and cracking process. Next is solvent extraction. So the overall mass balance is 374.05 kilogram per hour. And there is energy balance which is negative 1.5931 to the power of 9 joule. Then the composition is protein is 49.54%, fat is 1.08%, carbohydrate is 30.69%, water 10.69%, and mineral is 8.02%. So for the mixing, the first mixing is with the water. The overall mass balance is 411.5 kilogram per hour, and then there is no energy balance, and the composition is protein 45%, fat is nearly to 1%, carbohydrate is 27.89%, water is 7.29%, mineral is 18.83%. Next, the mixing with the aspergillus oryzae, the overall mass balance is 434.05 kilogram per hour. The composition is protein 42.07, the fat is 0.93, carbohydrate is 26.5%, water is 17.86, moisture is 6.91, aspergillus oryzae is 5.18%. For the fermentation, the overall mass balance is 430.61%. The energy balance is negative 1.2175 to the power of 5 joule. The composition is protein is 42.01, fat is 9.1%, carbohydrate is 25.86%, water is 70.8%, mineral is 6.97%, aspergillus oryzae is 5.23%. So for the filtration, the overall mass balance is 408.11 kilogram per hour. The composition is protein 45.38, fat is nearly 1, carbohydrate 27.29, water 18.99%, mineral is 73.35%. For the ultrapurification, the overall mass balance is 363.62 kg per hour. For the stress drying is 308.5 kilogram per hour, and the energy balance is 3.3 to the power of 9 joule. And then for the packaging and storage, the overall mass balance is 308.545 kg per hour.
Okay, so next I'll be explaining about task 5. Next. Okay, our task 5 is about how our plant will be located. So the location of our plant will be Pandamaran Pot Clang. Okay, the factors of choosing Pandamaran Pot Clang is because of 5 factors, which are strategic places, distance away from residents, rate of pollution in Pot Clang, incentives by government, and suitable for storage of raw materials. Strategic place is because it is near to the port. Distant away from resident, yes, because we are situated in an area where it is far away from the residential area. And rate of pollution in Pot Clang is average because that area has a lot of industries also. Incentives by government, yeah, because it is situated in Pot Clang, so Pot Clang is actually a free zone area. And suitable for storage of raw materials is because Pot Clang, it is near the port, and the company is around 5 km from the port. So it's very easy for us to store raw materials. Next. And number 6 is availability of energy. Yeah, because Pot Clang is situated in town area, so we will be getting our energy, which is electrical energy, from TNB. Waste disposal availability, whereby Pot Clang has itself, they have their own waste disposal system. And also, there are other bodies who will help out to dispose the waste properly. Number 8 is cost of transport of raw materials, whereby the transport costing will be quite less because the area is again in town area. So therefore, the ability for us to transport our product as well as raw materials is easy because it is nearby the consumers and market and also the port. Number 9 is availability of labours. Yeah, it's also quite easy because again it is near the port. Therefore, we can actually import, or we can actually take labourers from overseas. Number 10 is water supply. Water supply is from Sabah. And number 11 is safety, whereby again Pot Clang is a free zone, right? So therefore, they have a lot of rules and regulation for safety in order to prevent any accidents. Okay, this is our plant layout. It starts from the receiver room, so it goes away like that. And the control room is over there. Next. And this is our site layout. It starts from GH3, guardhouse 3. We basically have 3 guardhouse. Guardhouse 1, guardhouse 2 and guardhouse 3. Ours will be starting from guardhouse 3, whereby the raw materials will come in from guardhouse 3. And this is the unloading bay. So when you load up the raw materials, then we will handle the raw materials here, whereby we will like exchange, like loading and unloading of raw materials. Then it will go to the storage where we keep our raw materials. Then this is the processing area. Inside this processing area is actually the plant layout. Then this is the packaging room. All these are interconnected. Then this part is the admin, whereby it is considered like a main office of our company, whereby the admin, the cafe and the parking is not very near to the processing area. Then we do have R&D workshop for us to improve our products. And we do have our waste treatment so that we can treat waste efficiently. And yeah, so basically that's the gist of it. Okay, thank you. Sorry, there are also legislation factors whereby we need to follow 3 factors, which is Food Safety and Quality Control, Factories and Machinery Act 1967, and also Environmental Quality Act 1974. The rules actually varies according to the places. So ours is in Portland, so these are the 3 main legislative factors.
So for our task says, firstly our land purchasing price is 2.9 million, which is located in Port Klang, Pandaraman. And then next, the list of equipment cost is over here. And then for the cost of ISBL, which is calculating by times the solid processing plant, which is 3.1, and then our ISBL will be 5.6 million, and then our OSBL, which is 2.26 million. And then for the variable cost, our raw material cost will be soybean, aspergillus, oryzae, and hexane, and the total will be 11.131 million per year. And then our packaging cost, utility cost will be costing in total, our total variable cost will be 13.6 million. So for our total operating cost, which is times with the fixed operating cost and the variable cost, which is 15 million, and our total investment, which is total capital cost and total operating cost, which is 28.67 million ringgit Malaysia. So for our income wise, our income is solely depends on the sales of hydrolyzed soybean protein powder, which is 500 gram per pack, and then our sales will be 27.715 million per year. And then you can see this is our cumulative cash flow and net NPV graph per year. You can see that our payback time is around 2.97 years, which is at the 3rd year we can get our profit already. Yeah, so by calculating our plant design, our return of investment is 33.67%, and then our simple payback time, which is 2.97 years, meaning that if the investor invest 100,000 ringgit Malaysia, and then he can get back 33.67 thousand ringgit Malaysia as a return of investment. And then our simple payback time is around 3 years. And then for our IRR is 11.87%, which is quite reasonable.